Okay, so it's time to do some sample problems from the second section. That was the cat. The outside cat, that's Sam. So there were a couple of problems. If you chose to type your answers and turn them in for section 2, that's fine. If that's the case, you don't have to turn in number 2 on your problems. If you chose to write it out and take a picture like this, then it would have been great to have that problem in there, just so that I can give you some feedback and let you know how things look on those problems. So I'm going to do, this should say number 1. I'm going to do number 1. You guys were supposed to start with number 2. So the first thing I did here for number 1 was just to label a circle. And it's important that we know some key points of the circle. Once we get to the unit circle, when we come back from this little break, we'll talk more about all of the different angles and all of the key angles in a unit circle. But for this one, I just need to know basically what these little markers are. So 0 degrees, and then as we rotate around 90 degrees, 180, 270, and of course we know a full circle is 360. If we look at the same thing in radians, you can always translate those radian measures into degrees, but it's also really important that we know how to find both on a unit circle and how to do calculations with both. So this is 0, and this is half of a pi, so pi over 2. This is pi, 3 pi over 2, so 1.5, and then this very last all the way around for radians is 2 pi when we do that measurement. So let's label the ones for number 1. The first one says 30 degrees. Well, 30 degrees would be 1/3 of this measurement, so there's our 30. 300 degrees. Well, I know it has to come between 270 and 360, so it's going to be 1/3 over from 270. And these don't have to be perfect. You don't have to get out anything and measure them. But just an estimation so that you know about where this is going to be. Now remember, positive angles are counterclockwise, negative angles are clockwise. So if we want a negative 135 like the next angle in the book says, we need to start here and go down. So negative 135 is going to be about halfway. That's negative 135. So let's see if I can make it so you can see that problem just a little better. Next we have 70 degrees. So we know 70 would be kind of close to 90. And then there are 2 of these that are in radians. So 2 pi over 3. Now I know that a whole pi is half of a circle. So 2/3 of that, 2/3 is between 1/2 and a whole. So if we're looking at this as the whole thing, if I want to go to 2/3, 2/3 would be about right here. And then the next one, the very last one on that example, is 7 pi over 4. So 7 pi over 4 is more than 1 whole. So let's finish up those problems from section 2. The next couple of problems you were supposed to be changing to and from radians and degrees. So remember, when we want to have radians as the answer, we want to have pi as part of that answer. So that's one way we can remember what we're supposed to multiply by. Remember, we're supposed to multiply by either 180 over pi or pi over 180 when we want to change from one to the other. So I'm trying to get rid of degrees and introduce pi. So we're supposed to multiply by pi over 180. Now remember, when you multiply, you can multiply straight across. So if we just combined all of this together into the same fraction, we've got 180 pi over 180. those 180s actually can cancel out. So our answer for that one would just be pi. If that wasn't the case, we would simplify whatever fraction was there and just use that as our answer with pi's as part of it. So for this one, for number 5, we want to change from radians to degrees. So in this case, we really want to cancel out the pi that's in that value because usually we have pi as part of that answer. So when we multiply by 180 over pi, if we combine these two fractions together, the pi's really cancel out. So we've got 5 times 180 over 6 left. And really you can just type that into your calculator or simplify it in your head. And for this one, 180 over 6 is 30, and 30 times 5 is 150. So 150 degrees for that one. So 5 pi over 6 and 150 degrees, same thing. Let's continue with number 7. For this one, we're supposed to find a coterminal angle for 685 degrees that ends up between 0 and 360. So basically what we need to do is subtract full rotations until we get to something that falls in between here. So if we subtract 360 here, we end up with 325. Well, 325 is between 0 and 360. So if we were looking at that on a circle on our coordinate plane, 325 is about here. So that's 325 degrees from the beginning. This angle, 685, is a full rotation in addition to that. So notice if I go a full rotation, I still end in the same place. So that's why they're called coterminal. They have the same ending spot. But it just depends on how many times you go around that circle before you get there. So this one, 325 coterminal with 380 or 685. The next one is negative 1,746 degrees. So since this is negative and I still want my answer to be between 0 and 360, I have to add 360 over and over again until I get something that falls within that range. So if I add it one time, I'm at negative, oh, hold on, 1386. So I'm not there yet. It looks like this is going to take me a really long time. So I'm thinking I need to add maybe multiples of 360. What if I go ahead and add 720 in this time? So 720 is just 2 full rotations, and that way it can cut down on the number of times I have to add this together. So that gives us negative 666. I can only imagine what you guys would say in class if I added and we got that answer. We'd probably have to do something else. So let's add 720 one more time, so that's not what we end up with. If we add 720 here, we're going to end up with 54. So 54 is the answer that we were looking for this one. We had to add 1, 2, 3, 4, 5 full rotations in order to get to that angle. So that means that positive 54 degrees is the same thing as 5 rotations in this direction plus a little bit more to get to negative 1,746. But they both have that same final line to represent that angle. So for number 11, it's the same thing, but this time they've given you radians instead of degrees. If you really needed to, you could write that out as degrees and do it from there. But let's try this using radians. So remember, we have to add or subtract a full rotation to find the coterminal angle. So a full rotation for radians is 2 pi. So for this one, if I want 2 pi to have a common denominator, it's going to be 18 pi over 9. 18 pi over 9. So I need to subtract 18 pi over 9. See how they have a common denominator? We've got 26 pi over 9 minus 18 pi over 9. And since both of those terms have a pi on it, I can kind of treat the pi like a constant or a variable, and we can combine these two like terms. So that's going to give us 8 pi over 9. Now remember, it has to be between 0 and 2 pi. It has to be within one full rotation. 8 pi over 9 is a little bit less than 1. So that means that it would be a little bit less than 180 degrees. So that's where that terminal side would be for that problem. Okay, last one, we're supposed to be finding the area of a sector, and it tells us that the angle is 45 degrees and the radius is 6. So remember, the equation for area of a sector is 1/2 r squared theta. Now the important part here is that we remember theta has to be in radians. So we're going to have to change this 45 degrees into radians. So if we simplify 45 over 180, we should get pi over 4. So this is what we're going to plug in to the theta part. It has to be in radians. That's part of the requirement of the formula when we use it. So that's just the way it's got to be. So this is going to be 1/2 6 squared times pi over 4. Now, unless we're going to be using this for some kind of a practical application, like if we're going to be drawing it out or measuring it out, then we could change it into a decimal. In this case, really, we want to leave the pi as part of the answer. We want it to be as precise as possible. So if we multiply this out, 6 squared is 36. And we can look at this as 36 pi over, if we multiply those denominators together, it'd be 2 times 4. So if we simplify all of the number part and leave that pi value in there, we're going to end up with 9 pi over 2, or 9/2 pi, or 4.5 pi. However you want to represent it, but this is a precise answer, and that's something that we would want to use if we were going to do another calculation or if we were making comparisons between two different things. So if you have more questions, please feel free to let me know, but I hope this is helpful in that second section.